Hello y'all, we are going to do notes today over algebraic properties. You've learned most of these throughout the years in either elementary school or middle school math or maybe even algebra. So we're going to talk about those today. The first property that we're going to talk about is addition. Just like the name of the property suggests, when you do the addition property, if you start off with A equals B and you add the same thing to both sides, that's the addition property. Subtraction property says, just like the name suggests, if you start off with A equals B and you subtract the same thing from both sides, that's a subtraction property. When we're doing proofs, in which we're about to start doing soon, you can think of this part right here as the given. So it's given that you have A equals B. And then what you're trying to prove is that when you add the same thing to both sides, it's equal. All right, the multiplication property, if A equals B, and you multiply the same thing to both sides, so you multiply C to both sides, then it's still equal. The division property says if you start off with A equals B, and you divide both sides by the same thing, it's still equal. The reflexive property, think of it like your reflection in the mirror. If you look in the mirror, you see your reflection. It's the exact same thing looking back at you. So that's the reflexive property. We have A equals A or AB equals AB. We may do like segment AB is congruent to segment AB. A picture of that might be like this, where we have a triangle and we have a segment AB right here. That segment's congruent to itself. So that might be a way we might apply it in geometry. Or let's say you have a triangle like this, and this angle A right here, it's the same angle for this triangle as it is for this triangle. So we would say angle A equals angle A, something like that. And we'll talk about those more later as we get into proofs. Okay, so I'm going to move this up a little bit. Okay, next is the substitution property. It says if you know A and B are real numbers, and A equals B, then A can be substituted in for B. For example, let's say that I'm telling you that, I don't know, we've got A, oh, sorry, I'm using the wrong color there. Let's say I have A plus B equals 7, and I also tell you that B equals 3. Then I'm able to say that A plus 3 equals 7, and the reason is that I'm using substitution. What I've done is substitute in 3 for this B right here. That's using the substitution property. All right, the next one is transitive property. You have if A equals B and B equals C, then A equals C. Notice that we have A equal to B, but we also have B equal to C. So these are the same right here. So that means that these two must be equal to each other. That's the transitive property. We have three things there. The A equals B, the B equals C, so that means that A equals C. All right, distributive property. You guys have been using this a lot. You just distribute A through the parentheses to get AB plus AC. The commutative property tells me, and you use that for addition or multiplication, it basically just tells me that I can just change the order of the way those numbers are added. So A plus B is the same thing as B plus A. In other words, like 3 plus 2 is the same thing as 2 plus 3. Or if I'm multiplying, A times B equals B times A. Or 3 times 2 is the same thing as 2 times 3. Associative property just says that you can put parentheses around a different group. Like we start off with our parentheses around B plus C, but that should be the same thing as having the parentheses around A plus B. Those will stay equal. Or if you're doing multiplication, if you're multiplying those three things together, A times B is the same thing, in parentheses, is the same thing as putting B times C in parentheses. All right, let's do some examples. Okay, so for our examples here, we're just basically going to show the next step. So if we've got 3x minus 7 equals 14, and you're solving this, what you would normally do is just add 7 to both sides. So that would make it 3x equals 21. And the property that I used in order to do that was the addition property. I guess it's the property of equality, so I'm just going to abbreviate POE for that. All right, next you've got 5x plus 5 equals 10. In order to solve this, our next step we would do is subtract 5. And that would make it, oops, I don't know what I'm writing there. That would make it 5x equals 5. And we use the subtraction property of equality. Okay, next we have 1/2 x equals 3. Now technically that's the same thing as saying x over 2 equals 3. That x is being divided by 2. So in order to solve it, I'm going to write it like this. We're going to multiply both sides by 2. And that would give us x equals 6. So we use the multiplication property. Okay, next, to solve this, we have 5x equals 20. That 5 is being multiplied times x, so to undo it, we're going to divide both sides by 5. So that gives me x equals 4, and I use the division property. Next, if I'm going to solve this, I would distribute the 3 through that parentheses, and that would give me 3x, whoops, I'll write it over here, 3x plus 6 equals 1, using the distributive property. Okay, the next one we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3. And they're also telling us that the measure of angle 2 equals 30. So what I'm going to do is replace this angle 2 right here with this 30 because they're the same thing, they're equal to each other. So that will become the measure of angle 1 plus 30 degrees equals the measure of angle 3. And I use the substitution property to do that. Okay, next we have if the measure of angle 1 and the measure of angle, if the measure of angle 1, actually, doesn't say measure there, sorry. Angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Then that's using the transitive property. Basically, we have this in common on both of those. That means that these two are congruent to each other. So angle 1 is congruent to angle 3 using the transitive property. Okay, and this last one we have the same thing looking back at itself. That's the reflexive property. I don't know why I tried to make that all one word. I'm sorry. Let me fix that. All right, let's move on. Okay, for this next part, I think it might be a good idea if you practice these first. You go through 1 through 8, do them yourself, pause the video, go and do them yourself, and then check your answers with mine and see if they're the same. Okay, 1 sec. All right, I'm going to go ahead and explain it as I do it. So I've got if AB equals BC and BC equals CD, so the same thing. That means that these are going to be equal to each other. AB equals CD. That's the transitive property. Okay, next we have if 3x equals 120, then x equals 40. Well, it looks like what I've done is divided both sides by 3 to make that happen. So this would be the division property. All right, next I have if AB equals CD, then AB plus XY equals CD plus XY. So what has changed is that I've added this to both sides. So that's the addition property. Remember, this is always what you start with. This is your given. And this other part right here is your result. So that should help you kind of see what has happened from the given to the result. All right, next we have the measure of angle 1 plus the measure of angle 4 equals 48. And we have that the measure of angle 4 equals the measure of angle 3. So it looks like to me what they've done in the next step is they've replaced this angle 4 with angle 3. And that's because of this right here. They use substitution to make that happen. All right, next we have if 3/4 x equals 20, then 3x equals 80. So I had 3/4 x equals 20. I'm pretty sure what we've done is multiplied both sides by 4, because that would take care of this division by 4. So that gave us 3x equals 80. So that was the multiplication property. We multiplied both sides by 4. Okay, next we have hn equals yt. Then hn minus ab equals yt minus ab. We've subtracted the same thing from both sides, from the given to the result. So that's the subtraction property. All right, next, that one's easy. It's the reflexive. Oops. Okay, and then next we have if HG is congruent to segment CD and segment CD is congruent to segment LO, then segment HG is congruent to segment LO. So we've got the same thing here and here. That makes these congruent to each other. That's the transitive property. All right, let's do some more. All right, we're setting you up with proofs with algebra because you're used to doing algebra. So we thought it would be a good way for you to kind of ease your way into it. So we've got an example here of an algebra problem that you would want to solve for x. This first statement right here is what you were given as a problem. So we write it, we first of all, we have a column for statements and we have a column for reasons that allow us to make that statement. So we've been given this problem, 2x minus 7 equals 1/3 x minus 2. It was given to us. That's our reason for being able to say that. So the next step that we're going to do, it looks like, is we want to take care of this 1/3 right here. So we're going to multiply both sides by 3. And we're able to do that using the multiplication property. All right, next. We end up distributing that 3 through the parentheses. So from 2 to 3, our process was the distributive property. That's what allows us to get step 3. All right, the next step, we went from 6x minus 21 equals x minus 6 to 5x minus 21 equals negative 6. And to make that happen, we subtracted x from both sides. So we used the subtraction property. Okay, next, to go from step 4 to step 5, we took 5x minus 21 equals negative 6, and we moved the 21 to the other side and got the 5x minus 15 using the addition property. All right, next, we want to go from 5x equals 15 to x equals 3. So to make that happen, we divide both sides by 5 using the division property. And we are through with that proof. All right, let's do another one. So this time, we weren't given any statements. They didn't spell it out for us. We're going to have to do it ourselves. And this is a literal equation that students struggle with every year in algebra. So we're going to do it in geometry just to help you practice. So our first statement is that SA, or surface area, equals 2 pi RH plus 2 pi r squared. And what allows me to say that is they gave it to me right here. So it was given. I'm going to erase some of this over here just to get it out of my way. Okay, number 2. Now what I'm trying to do, my last step should be have this solved for h. So what I'm trying to do is to isolate this h. I want to get that all by itself. So whenever you're solving a problem, you always undo your order of operations backwards. We start with parentheses and exponents, multiply, divide, add, and subtract. And we work our way backwards when we're solving. So we have to undo any adding and subtracting first. Well, we've added to that h, we've added right here the 2 pi r squared. So I'm going to subtract that from both sides. I'm going to move that 2 down a little bit just to give us more room. Okay, so right here, those are not like terms, so we just rewrite both of them. SA minus 2 pi r squared equals 2 pi RH. Now this canceled, so it's gone away. Now again, we're trying to solve for this h right here. Right now, what's happening to that h is that it's being multiplied by 2 pi r. And the way we undo that multiplication is we divide by it. So our result will be SA minus 2 pi r squared over 2 pi r equals h. I'm going to erase some of this that I already did right here. You can go back and look at it again, but I just want you to kind of see what the actual proof looks like. So, again, my reasons, I forgot to say that over here. From step 1 to step 2, we subtracted 2 pi r squared from both sides. So we used the subtraction property. And then from step 2 to step 3, we divided both sides by 2 pi r. So that was the division property. And because our result has h equals, we have finished that problem. We have solved for h like it asked us to do. Okay, last thing on these notes. It says here to rewrite the conditional statement by separating the hypothesis and the conclusion. The hypothesis becomes the given information and the conclusion becomes the prove information. So this part right here, if you'll remember from last class, that is our given, because that's the hypothesis. This part is my conclusion, the then part. So that's going to be my prove. So when they ask me for the given information, what's been given to me is that the measure of angle ABC is equal to the measure of angle LMN. Make sure that looks like an angle. The prove part then is going to be that angle ABC is congruent to angle XYZ. Okay, that's it for these notes. Thanks, guys.